All right, so we are not finished with trig, but we're starting a new unit that's not called trig, but trig is definitely involved within it. And this, I already forgot, is going on page 126 when we are done. So we're going to look at the polar coordinate system. So let's take a second to talk about the rectangular coordinate system, or the Cartesian coordinate plane, the XY axis, all that stuff that you already are very familiar with. So if I have a point on the XY axis, okay, and this is just your plain old X and Y, and I plot this point here, and this point is at 2, 2, right? So to get to that point, we start at the origin, right? We go to the right 2, and then we go up 2. So this is 2 and this is 2. That's how we get there, right? And so then there's this distance from the origin to that point. What would that distance be? It is the hypotenuse. Specifically, what is it?
Oh, you mean the number.
The number.
The value.
How long is it? What is this length? This is a really easy question. 2 square root of 2. There you go. Yes, 2 square root of 2. Okay, so because that has to be a right angle because the X and Y axis are perpendicular, right? And we know that for sure because this angle here is what? What's the measure of the angle? 45 degrees. Okay. So usually when we're plotting points, we have the 2 and the 2 because that's in the ordered pair. We don't care about the 2 square root of 2 part unless we're actually finding distance or something. But there's a different way to get to this exact same point right here. Okay, and we can still talk about the fact that we're on the X and Y coordinate system. Like, I won't change that on you just yet. But instead of going X and Y and thinking in the rectangular coordinate system way, instead I could swing out from here. This is 0, right? And I could rotate 45 degrees. So here's the 45-degree angle here, right? And then on that 45-degree angle, I could go out a distance of 2 square root of 2. Wouldn't that get me to the exact same point without using rectangular coordinates, right? Okay, it would. And it might seem like, why the heck would we want to do that? There's lots of reasons we would want to do that. But when we look at different types of coordinate systems, because there's not just rectangular and polar, there's other ones too, which we'll talk about a little bit. But we're talking about the same points, like the same point in space. It's just a different way to notate its location. Okay, a different way of, telling us how to get there or how to get there. So we're going to be looking at angles and distances instead of X and Y. Now, when you plot these points, we always do X and then we do Y, right? We go to the right, then we go up, or we go to the left, or whatever it is. Could I do Y before I do X? Sure, I could have gone up 2 and over 2, right? As long as I don't get X and Y mixed up, it's fine to do the Y first. We just don't do that, and it would seem weird, right? We always do it the other way just to stay consistent. So I want you to keep that in mind as we start to talk about how to graph things and how to look at things on the polar axis, okay? So this says here, up until now, you have graphed on a rectangular plane containing an X and Y axis. We will now look at another system called the polar coordinate system, all right? So we have a point. It says fix a point O. Here's our point O right here. It is called the pole or the origin, but pole is really what we go with here. I mean, it is the origin, but. Okay, so from this point O, which is our pole, we construct an initial ray. So this is the ray right here. And this thing is called the polar axis. Where in the rectangular coordinate system, you have an X and a Y axis. They are intersecting lines, and where they intersect, that is the origin. For the polar coordinate system, you only have one axis, and it's a ray. This is my polar axis, and the origin or the pole is the endpoint of the ray. Okay? So it says each point P, here's point P, is in the plane and has the polar coordinates r comma theta. R is the directed distance from 0 to P, or not from 0, I'm sorry, from O to P. And theta is the counterclockwise directed angle formed by the polar axis, and this should be line segment OP. So when we're plotting these r thetas, they all make a whole lot of sense. But then when you get that r is negative, you have to handle it a little bit of a different way. So when r is negative, I'm going to give you the rule, but I don't necessarily, and I'll show you how the rule works, but I really think reasoning through it and understanding the concept is better than remembering what formula to substitute it into. But when r is negative, you graph a positive radius and then theta plus pi. And I'll explain that when we don't even know how to plot them yet, but we'll get there. Just get all that written down. I'll show you how it works. It's really very, very simple. The negative, you just have to make sure you can wrap your mind around it. It's not difficult. It might seem kind of weird at first since you haven't done this before. All right, so this is your polar grid. Okay, it's made with concentric circles. It actually says that. Concentric circles are frequently shown on the polar coordinate system. So concentric circles just means they have the same center. This is what a polar grid looks like. You may have seen it in something before and just wondered what the heck was going on here. But that's because we're worried about rotations and the angles, kind of like living in the unit circle here. So the unit circle really goes on the, on the polar axis here. And here's our polar axis. That's our pole. And we just have this one ray and then all these circles, and some of those angles are already labeled for you. So remember how I asked you, could we graph, when we're graphing rectangular points, 3, 2, whatever, could we do y and then do x? Yes, as long as we still do it that way, it's fine. So most people, I mean, you don't have to, but it's easier really to do the angle and then the radius. So you figure out where you are in your angle, and then you put your radius on there. It's kind of like doing it backwards. So if I'm starting here, I'm going to rotate around to 7 pi 6th. Here's that 7 pi 6th angle. And then on this radius that makes this 7 pi 6, my radius is supposed to be a length of 2. Notice on here that every circle is a half. So here's 7 pi 6, so that's 1, that's 2. There's my point right there. This is point A. So I rotated around to 7 pi 6 and made my radius 2. That's it. So you try and graph B. See if you can graph B and make some sense out of it. Three pi fourths isn't labeled on the circle, but you should know where it is, right? So I rotate around to 3 pi fourths. That's this right here. My radius is 0.5, so I'm right here, and that's B. Easy enough? All right, so then for number 3, C. This is a negative pi thirds. So that means I'm going clockwise, right? So negative pi thirds is the same as positive 5 pi thirds. So here's my angle. And then my radius is 3, so I'm way out here, and that's C. Everybody okay with that? All right, so now we've gotten to a negative one. So let's talk about D and how we want to look at this. First thing I'm going to do is go to pi fourths. So pi fourths is right here, right? I don't want my radius to be 1. I want it to be a negative 1. Well, this says that if r is negative, I'm really graphing a radius of 1, a positive 1, and theta plus pi. Well, what is pi fourths plus pi? Five pi fourths, right? Okay, so 5 pi fourths is right here, and here's my radius of 1. So I did it by the rule, but we're going to look at a different way to do that here in just a second. So that's D. Because really adding pi to pi fourths is not that big of a deal, but it still took y'all a second, right? And if the angle is weirder, it can just cause issues. You don't need to actually come up with that value. Look here, this is 5 pi fourths, right? This is pi fourths. We're talking about the radius here, but do you notice that that's just the same diameter, right? So instead of worrying about adding pi, every time when you add pi, you're just going to the other side of that diameter. So if I rotate to pi fourths and then I pass through the pole to get to 1, that's the easier way to graph it. That's the same as adding pi without you adding pi. Does that make sense to you? So you just rotate, and if it's a positive 1, it's over here. If it's a negative 1, you pass through the pole. But the reason you're passing through the pole is because what you're doing is adding pi. Okay, like we're using the rule, we're just not thinking of it that way. Okay, so you try and do E that way. Number 5, E. Okay, so I'm going to rotate. I'm here. I'm going to rotate around. Here's 4 pi thirds. Oh, bless you. Here's 4 pi thirds. But I have a negative radius. So I'm going to pass through the pole to pi thirds and then go 2.5, which is right here. And that's my E. Okay, everybody good with that? Okay. So then now you have a negative angle and a negative radius. Do F. See if you can get F on there. All right, so I'm going to go negative pi 6, which is the same as 11 pi 6. But my radius isn't 3, it's a negative 3. So I have to pass through the pole, and this right here is F. Bless you. Are we all good? Yes? Graphing makes sense? It's simple? Okay, good deal. All right, so then it says, while each pair of polar coordinates plots a unique point, each point does not have unique coordinates. There's an infinite amount of ways I can get to each one of those points, right? Because I could keep rotating around like running around the track. So in general, a point with polar coordinates, r theta, can be represented by blank. Okay, so I'm going to give you a rule here as well. And it can give you an infinite amount of answers. I'm not a big fan of the rule. I think you being able to reason through what it is better, and it sticks with you better, because unless you're just a formula person that remembers them and then can apply them, this isn't something you'd see on a formula chart. So you'd have to just know what it is. It's way easier to remember the concept and how it works instead of just trying to substitute things in all the time. So it looks like this. R, comma, theta plus 2 pi n. Which makes sense, right? Because you're just, going around. And then, or negative r theta plus 2n plus 1 times pi. And I have to look at that to write it, or I'm going to write it wrong, because, again, I don't use that. I don't know that that's the best way to do it. So let's talk about really kind of the easy way to think about what's happening. I think it helps to have you have this point plotted. So like here's my circle, there's my polar axis, right? So I'm going to plot this point, this 5 pi thirds. 5 pi thirds is in which quadrant? The fourth. So it's like down here. I'm not even going to draw the quadrant necessarily. I just know that it's in the fourth quadrant. And then that length can be 2, because the 2 is just, it is what it is. So we're trying to figure out different ways to get to this exact same point. Well, if I'm still using a positive radius of 2, instead of going a positive 5 pi thirds, I could go a negative what? Pi thirds. Okay. And then, so I have 2 with a positive radius, and then I'm going to end up with 2 with a negative radius. Okay, so what I do, just to keep it consistent, not that you have to, but if I start with a positive one, I'll do the other positive one first. If they give me a negative one, I'll do the other negative one first, just so I can make sure I got it all done there. So my negative radius would mean then that I actually need to end up here with my angle, because then I'm going to pass through the pole, right? So how would I get to the second quadrant pi thirds angle in a positive direction? 2 pi thirds. How would I get to that same angle going a negative direction? Negative what? Negative 4 pi thirds. See how that works? Just if you have a picture there to kind of refer to, you can help yourself get there. Now, also notice the angle measures. Kind of ignore the negatives for just a minute and just look at the 4 angles that we have. You notice how we used all 4 pi thirds angles that are in there? Okay, so every time, 2 of them will be positive and 2 of them will be negative. And you'll have 2 positive radius, 2 negative radius. Okay, we good? That way, if it comes up, it's not going to tell you, it's not going to be the same pattern every time on which one's positive and which one's negative. But if you had a positive 4 pi thirds and a negative 4 pi thirds, you know something's wrong, because you shouldn't have 2 of the same thing. Okay, we good? All right, let's look at the next one then. We're going to do 8 together as well, and then I'll have you do 9 on your own. So I'm going to draw my little circle. Right. I'm going to plot my point. So negative 7 pi fourths puts me in which quadrant? The first, so I'm like here, but then I have a negative 5, so I end up here, right? So I started with a -5, so I'm going to use it. I'm going to do the other -1, and then I'll have 2 positive ones also. Okay, so that means that, so the -7 pi-4 got me here, and then I passed through the pole. How do I get here with a positive angle? Pi-4. So it'll be pi-4 with a -5 radius. And then if I'm going to have a positive radius, that means I actually want to land here. What's my third quadrant pi-4 angle? 5 pi-4. And then to get there going the negative direction, -3 pi-4. Good. All right. Any questions at this point? We all good? Yes? All right. I want you to do number 9. You're done. Make sure we agree. It does not matter what order you write them in. Well, the r theta order matters, obviously, but if the order pairs, you wrote the different one first, that's fine. It doesn't matter. Just make sure you have those 3. Any questions at all? We good? All right. Okay, so let's talk about the distance. So when you've done the distance formula before on the x-y axis. If you don't know what the distance formula is, because I would think at least some of you wouldn't be able to rattle it off at this point. Remember, it's that big old yucky square root thing. But what could you use instead of that? Like, you want the distance between 2 points on a coordinate plane that you already know how to do. The distance formula, you don't have a formula chart, you don't know what it is. How can you find the distance between those 2 points? Pythagorean theorem, right? Because isn't that where the distance formula comes from? Comes from the Pythagorean theorem. So if all else fails, you can do the Pythagorean theorem, right? So let me remind you about the distance formula, which I know for sure you do in geometry. You might have learned it in Algebra 1. Also, sometimes it's an Algebra 1 thing, sometimes it's not. But so here are your 2 points on the coordinate plane, right? So if I want the distance, see, this is when we came up with the distance formula. Use Pythagorean theorem. These are the actual distances when you don't have numbers in there. And then you end up with this, right? But if you don't know what that is, if you can just connect these 2 points and, put your little dotted lines, find these links, you can do Pythagorean theorem, right? That's important to know in case you don't remember what this is. Well, on the polar coordinate system, you don't get to use the Pythagorean theorem. That doesn't work. But it is tied to the law of cosines. So find the law of cosines. I believe it's on page 99 in your ISN. Find that. And then underneath this circle, leave yourself some space, but then we're going to write the law of cosines like right here. All right, so there's 3 different forms of it, right? And they're pretty much all the same. It just, because those letters aren't usually what's in your triangles anyway. But who wants to give me one of the versions? Anybody? Somebody? Anybody? Oh, cosine of A. Oh, goodness. Let me write this where you can read it. All right. And at the top of those notes is kind of where it comes from. That was a little bit more, I mean, it just works out from, you know, that comes from something else, and then we use that here and go on and on. So here, if I have this triangle, right? So find missing sides of triangles that aren't right triangles. Hopefully that doesn't look like a right triangle. So if I'm looking for A, this length would be A. That means this would be angle A, which we called angle A here, but it's also the angle that we have. We'll call it theta. And then we're going to have B and C. So if this is little b and this is little c, that means this is capital B and this is capital C, right? So in order to find A, this length here, we would have to know two side lengths and the included angle, right? That's in a nutshell what the law of cosines is. It allows you to find that missing side when it's not a right triangle if you know the side angle side part of it, okay? So let's look at how that works here. So you have these two points that are plotted on your polar axis. This, and it's teeny tiny, this is P1, right? I had trouble even seeing it on the notes. Yeah. I'm going to write this bigger because I can't see it. P1, and this is P2. Okay, so there are 2 points. And we would know these ordered pairs, just like you would know X and Y for both ordered pairs if you're using the distance formula on the rectangular coordinate plane. So I know these two. I'm not making a right triangle out of this like we would on the rectangular coordinate plane because we're not dealing with that. But I would take these 2 points, and if we connect them to the pole like this, we get a triangle. It's possible you end up with the right triangle. I mean, that's definitely possible at some point, but it's not a guarantee. So we want to make sure it works for all of them. I would be looking for the distance between these 2 points. That would be the D I'm looking for right there. The length of this is the radius here, right? This is r theta. So to get to this point right here, I would have rotated and then gone out that radius. So this is r1, which means this has to be r2. Everybody understand why that is? Okay. Then I also need this angle that's coming off the pole here. Well, here's what I know. I know to get from the axis all the way here is theta 1. To get from the axis here is theta 2. So how do I figure this out? Subtract them. So it's theta 1 minus theta 2. So now I have the two sides and the included angle, because the r's and the thetas are something we would have if we have the ordered pairs. Okay. So to take this and use the law of cosines then, the distance that we are looking for, d squared, is equal to r1 squared plus r2 squared, right? Those are our two side lengths that we have, minus 2 r1 r2 times the cosine of theta 1 minus theta 2. So basically I just took what I have here and substituted it into my law of cosines. Everybody good so far? All right, good deal. So when we come up here, just like when we get the distance formula in the rectangular coordinate plane, we don't care about d squared. We want d. So here is just the distance, and here's the big old square root here. And this is r1 squared plus r2 squared minus 2r1 r2 times the cosine. Now here we wrote theta 1 minus theta 2. The actual formula, if you ever saw it on a formula chart, would most likely say theta 2 minus theta 1. We'll talk about whether or not it matters here in just a second. In the rectangular distance formula, it totally doesn't matter if you subtract backwards because you're about to square it, right? Because if you subtract backwards, all that's going to change is the sign. But when you square it, it doesn't matter. Here, are we squaring anything? We're not. So we'll see if it matters here or not in just a second. Okay, everybody good so far? So the good news now is this is just kind of a plug and chug type of thing. You have the ordered pairs, you have the formula, you substitute it in, and you move on, and it shouldn't be that hard. So let's look at number 10. D equals big old square root. So this would be r1 theta 1, r2 theta 2. So this is going to be 2 squared plus 3 squared minus 2 times 3 times the cosine of, and that's theta 2 minus theta 1, so it's 7 pi fourths minus pi thirds. Even when the numbers are simple, don't do too much of this in your head. I know you know what 2 squared is. I know you know what 3 squared is. This is where the ridiculous mistakes happen when you try and combine things quickly in your head because you think it's easy. Why do I have to write that out? Well, this is writing out the rule. Now, the 100% of this can be done in the calculator now. You don't have to write anything else out. Okay? But does my calculator need to be in degrees or in radians? Radians. Your calculator is most likely in degrees right now. Okay, so let's talk about how to change that. Or if you're not sure because it's so little you can't even read it, because I know that thing's tiny. So once you turn your calculator on, you go to Shift and then the mode key, which is right next to on, and then 4 for radians. So Shift mode, mode is right next to on, and 4 for radians. Okay, so even if it's already in radians and then you do that, it's just kind of assuring you that it's that. And son, the next time you are not getting up and interrupting my class, go get a calculator. It was on the board, it was said yes, and I said it at the beginning of class. All right, so now that it's in radians, you can do 100% of this. Start with the square root sign. Now here, when I write it, I prefer to use parentheses when I write it, so if I'm doing multiplication, I don't get it confused with my bad handwriting with my minus. But in the calculator, you don't have to put all those parentheses. But here's what I want you to do. Hang on, don't get too far ahead. When you go to type these parts in right here, use the fraction key. But I want you to choose one person at your table to type this in the other way, doing pi thirds minus 7 pi fourths. Like a theta 1 minus theta 2. Just one person at your table, type everything in the same, but just reverse those. And everybody else just type it in like it is. You can do it all in one step. And on these, you absolutely have to close all your parentheses or it will give you an error. Okay? So get it all typed in. Let me know if you're having issues. The pi button is down underneath the scientific notation down at the bottom. Mm-hmm. Mm-hmm. Oh, really? I mean, oh, that's weird. I mean, it's not a major issue, yeah. But I just want to... Oh, I can't. That's strange. And it's even like the same version and everything. Huh. Look at that. Weird. Just make sure you close your parentheses and you're good. Does that make sense? That's, yeah. All right, so what do I put? What's my answer? 4.01. I know we make a big deal about 3 decimal places, but the truth is sometimes it can come up with something else. It's 3 decimal places unless you are told otherwise. And if you're told otherwise, you have to do what it says, okay? Now, those of you that typed it in backwards, did you get the same thing? Yeah, and we didn't even square anything. No, not on here because it's just straight up distance. But let's think about why it didn't matter. Because if you subtract in the opposite way, some of y'all use negative angles, even though you didn't realize it. So, but we got the same thing. Remember on your chart, it says cosine of negative theta equals what? Cosine theta. So they are the same thing. So even though if you subtract the other way and you get a negative angle, you're going to get the same cosine value because of the way cosine acts. If this was sine, it would be a whole different issue. Okay, we good? Blows your mind, right? All right, I want you to do number 11. I want you to write it down, substitute it in, whole 9 yards. Did anybody have any issues? Let me know if you are, okay? So make sure we agree, do not just write my answer down. Make sure you are typing this in and getting this. And if you are not, let me know. if you get an error, it's most likely a parenthesis issue. And you can scroll back and fix it. You don't have to retype everything. What's error?
I pressed the wrong button.
Oh. I hate that. Okay. You might not, no, you don't necessarily need to start over. You can go back up, go up, up. Oh, there you go. And then, oh, I went up too far. You can go back down. Sorry. Is that what you got? What are you laughing at? You didn't get the right answer? Let me see what you're typing. Give it to me now.
Can I go back down?
But you can go over. That's what you want to do. Oh, go back down to the other. Yeah, I don't know how you do that because you went too far up. Is that what happened? Yeah, I don't know. Yeah. Oh, I know. I probably know why. It might have had something to do with this. You can use the fraction button there. Did you know that? Try and do it again and use the fraction button so that you don't mess anything up on the fractions. You don't have to use the fraction button, but I mean. All right. Anybody else having major issues with this? We got it? We got it? Uh-huh. Yes. Oh, you added these before you squared them. They're squared separately. You don't have it written down right either.
Oh.
See? You square them separately. That's why. All right, everybody else good? All right, let's move on to number 12. So D equals big old square root. Oh, here's another thing I want to remind you of if you're not getting the right answer and you're not speaking up, that -1 squared and -1 squared are two completely different things. So when you type this stuff in, if you know that you're squaring it and it's negative, I mean, at 1, you can just put 1 anyway, I know that. But let's say it was like, I don't know, -17 squared. Then you could just put 17 squared and leave off the negative so you don't mess something up. Does that make sense? When you're writing it, though, you have to write it the correct way. So even though in my calculator, like this is 8 squared plus, and then this is going to be -2 squared, even though in my calculator I might put 2 squared, or maybe even I put 4, when you substitute it in, you have to substitute the correct numbers in, because if you're getting points for process, this is what you're showing that you're actually doing. Making, doing a little couple of different things in the calculator is fine. Then -2 times 8 times a -2 times the cosine of 310 minus a -175. And also here, in the calculator, if you want to just go ahead and do 310 plus 175, that's fine. There's absolutely nothing wrong with that. Okay? But what am I going to have to do before I start typing this in? Shift it back into degrees. So change it back. Remember, it was shift mode. Then just choose degrees and then do your thing. Do your thing. Okay, I'll come help you. This is what you should get. I'll put it up there so you can check and see if we know. Error is probably a parenthesis issue, so before you go up too far, let me see. Yeah, okay, that's fine. Oh, look, you put 2 pi 3 over 3. And so I think it probably made it too big, so I can take the... All right, we're getting it. Remember, don't just write this down. Type it in. Let me know if you're having issues. Pearl, did you get it that time?
Yes.
Yeah, okay, good. Good. All right, so if once you agree with me on 12, go ahead and do 13, 100% on your own. This time on 13, somebody asked me about units. You do need units because it is an application problem. Once you agree with me and have the correct answer, then you can go ahead and glue or tape this in. And once everybody's to that point, I want to go over one thing on the homework with you. There's not a mistake or anything. And the homework is one-sided, and that's not a mistake. I know. Let's see. I want you to look at on the homework. All right, let's look at number 2 on the homework. All right, because it's asking you to graph 7 pi 12ths, which is not an angle that you know, but it's an angle you should be able to figure out. But since last period everybody freaked out and didn't want to use their brain, let's talk about how to think about this. For this, 7 pi 12ths, if you just think about pi 12ths is how much of pi 6ths? Half, okay? So pi 12ths would be like right here, right? Okay, so when I get to pi halves, if I'm thinking in terms of 12ths, isn't that 6 pi 12ths? Which means 7 pi 12ths is just one more. Make sense? I mean, that's how you want to think about it. And so when you're trying to figure out where it is, this would be 12 pi 12ths, so this would be 11 pi 12ths, this would be 13 pi 12ths, and so forth. Like, think about those, think in terms fractionally, and you can figure out any of them. Okay? And you should be able to do the rest. I'm not going to tell you how to do it all.